All right. Oh, sorry. What's the name? So welcome to lesson outcome 3. Welcome to lesson outcome 3. And we look at exponential and logarithms. So in learning outcome 3, we have exponential and logarithm. We still have some other ones. Apart from that, we have arc of a circle. We have how to also solve Pythagoras theorem. That is what we're going to do in learning outcome 3. So so far, again, so far we look at because you look at the functions and this. So let's look at so in an exponential function, the variable is in like index form. So example of that includes when you have something like this, y equals to 2 to the power of x. That's exponential functions. Can you see? They're in what? They're in index form. Index form means that they're in powers. So index form means they're in powers. So the general form for exponential function is this, where a is what? Is more than 0. You can see that these x variables, they must be more than 0 and not equal to 1. So when you see a sign like this, it means not equal to 1. So for example, now, if they give you like a set of numbers, for example, now you have y equals to 2, x plus 5. This is example of an exponential functions. It must not the what's it called? This a must be more than what? Must be more than 1. If not, it's not going to be an exponential functions. It's not going to be an exponential function. So let's try and look at this. So graphs now, some graphs in exponential functions. So graphs in exponential functions are not always they're not a straight line graph. So it's either you have a graph like this, or you have a graph like that. So these are what exponential graphs. You can see that one steady. So when a is greater than 1, you get it for both of them. And this one is what? When a is between 0, you get it, but less what? But less than 1. That's what you actually want to see there. You see those ones, and don't forget that this is like when you see something like this, like a positive thing. You see, so it's like a direct reflection on the other one. It's like a direct reflection of the other one. So this is an example of what? Of exponential graph. So let's quickly look at so find P if P cube equals to this. When you say P cube equals to that, you have to do the opposite of cube. Opposite of cube is cube root. What's the cube root of 3? 4, 3. That's 7. So if they ask you that a cube equals to 1, 2, 5, then a will be equal to what? The cube root of 1, 2, 5. A is going to be equal to what? It's going to be equal to 8. Sorry, I put a part sorry. A is going to be equal to 5. I'm not used to that. It's going to be equal to 5. Because the reason why it's going to be equal to 5 is this. 5 times 5 times 5 equals to 1, 2, 5. . 5 . 5 . 5 . 5 . 5 . 5 . 5 . 5 . 5 . 5 . 5 . 5 . 5 . 5 . 5 . 5 . 5 . 5 . 5 . 5 . 5 . 5 . 5 . 5 . 5 . 5 . 5 . 5 . 5 . 5 . 5 . 5 . 5 . 5 . 5 . 5 . 5 . 5 . 5 . 5 . 5 . 5 . 5 . 5 . 5 . 5 . 5 . 5 . 5 . 5 . 5 . 5 . 5 . 5 . 5 . 5 . 5 . 5 . 5 . 5 . 5 . 5 . 5 . 5 . 5 . 5 . 5 . 5 . 5 . 5 . 5 . 5 . 5 . 5 . 5 . 5 . 5 . 5 . 5 . 5 . 5 . 5 . 5 . 5 . 5 . 5 . 5 . 5 . 5 . 5 . 5 . 5 . 5 . 5 . 5 . 5 times 5 times 5 equals to what? 125. So, and that means that if you have like, when if you say that 5 to the A is 125, you know that A is going to be 3. So in some cases too, this thing would not be this thing would not be what's it called? This thing would not actually be a standard. It might not be in whole number. It can actually be in decimals. So it does not actually matter. It's just let for you to know exactly what to do on that. So another thing that we must actually consider is another thing was consider is this. This is defined as this. So y is equal to the logarithm to the logarithm to the base this and this. So the expression y equals to log ax and this. So when you look at this type of logarithm function and y equals log b, so that means that you have to know this thing is very important. If you want to express x in terms of a and y, so x will be equal to what? The base of the logarithm a to the power, the one that is equal to is the power. So if you have a equals to log bc, a equals to log bc, b to the power of c, just put b to the power of a will be equal to c. You see, b to the power of a will be equal to c. So that's what actually was seen from that expression. So if you have 2 to the power of 3 equals to 8, so if you have to do this one log, it's going to be like log 2 8 if we go to 3. Just similar to this one too. This 2 is going to be the base. The answer is what is going to be equal to, and log 2 base this gives you that 1. So you can pause this thing. I'll ask you to do 3 cube equals to 2 to the power of 4 equals to 81. Can you pause the video and try and do this question? Express it in logarithm. So it should be what? Log base 3, 81 equals to 4. Equals to 4. So that's actually how the expression actually what it looks like. In some situations too, you can say log this as equals to this. So log, if you put this one that's a to the power of log ax equals to x, y equals to, you can also express y as this. The same thing. So for example now, y to the power of log 7 2 equals to 2, log 3 6 equals to 6. That's it. So let's look at this expression too. When you say that there's six indices, when you say that anything raised to the power of 0 is 1. So a to the power of 1 equals to 1 equals to a to the power of 0 equal to 1. So you have to know that. So when you say log, log a will be equal to 1, log a 1 like this equals to 0. So the multiplication law. So let's look at the multiplication law too. So when you see that m equals to log ax and n equals to log ay, s equals to so you have already expressed you have expressed that m and n equals to this. So x to the power of x will be equal to what? A to the power of m. My y equals to what? A to the power of n. So when you say xy is equal to what? Am this. So can you see now? So xy will be equal to what? Am plus plus n. So if we look at that word, if you have to take the logarithm of both sides, it's going to be log base a equals to m plus n log x. So you can also express log ax plus log z equals to this one. So that's how to prove it. That's how to prove that the multiplication law is actually what? It's actually what? Valid. Can you see from, if you express this one and when you multiply them together, it turns to what? It turns to this. That means that multiplication means what? Adding the log. So if you ask to multiply the logs together, what is xy? It means that x plus y. The same base of that. So you can actually pause that and see, you can try different letters there to see maybe it's going to actually work out. So that's how to do the multiplication law. So then the second one is that you can see that the power law to m equals to as a function of this. So then x is if x is this, so that means that x equals to what? Amn. Then mn is log a x to the n. Then it's just a proof to show you, that what's it called? N log ax equals to the same thing as that. So look at example for it now. Express this minus this as a single logarithm. So you should see what? Express that as a single logarithm. Express that as a single logarithm. So when you say 2 log a, don't forget there's going to be a power law here. When you say log a2 and the first and the third, we have what? Power laws. So just from the previous slide I showed, this one is going to be 3 squared, this one is going to be 6 squared. So you have to do the power first. Don't forget your big mass too. That, always work on the indices first. So when you actually were done with that, 3 squared is 9, then the 6 squared is 36. So you have this. Then the next point is that you know that 9 times 2, that's 18. This, I told you earlier that addition means multiplication. So you add them together and divide this. So 9 times 2 is 18 divided by 36. That's going to be 0.5. So this. So express log this thing is in terms of this, and this. So when you look at this too, you have to see how you can actually split it into two. So you see the division there clearly there. That's why the division is here. Then you know that this is a product. So you need to like addition, then minus e to the power of 4. So 2 log A, log 10A plus 1 over 2 log B. This. So logarithm to the base of 10 are usually what's written as log together. So that's the reason why you might not actually show that. So it gives you 2 log A plus have 1 over 2 log B and minus 4 log C. Logarithm to the base of 10 and to the base of E. Logarithm to the base of 10 to the base of E. So although the base of a logarithm can actually can be any positive number, there are only 2 bases that are commonly used. So there are logarithm to the base of 10 and logarithm to the base of E. So logarithm to the base of 10 are usually what's useful because our number system to the power of 10 on the power of 10. So I'm just going to give you an example of that so that one can become a little bit more clearer. So when you say let s equal, when you say suppose that we want to calculate the value of this, just say let s equals to this. So we want to find out the value of that, let s equals to that. That means that 5 to the x is 8. So you can see that one clearly that you want to find out the value of this because you cannot really put that one in the calculator and everything. So except you are using this graphical one. So what you need to do basically is that you just represent that one by a number. It's x equals to log 5/8. Then that means that 5 to the x equals to 8. What do you do after? Then you take the log of both sides. Log 5x equals to log 8. So that gives you what? X log 5 equals to log 8. Then x will be equal to log 8 divided by log 5. That is log 8 divided by log 5. So you can see that one. So just divide log 8 by log 5. That is the answer. So that's very straightforward. So you can try something like this. Just you can do log 5 log 5 9. So try and do that one. Then so it should be giving you it should be arriving at x equals to log 9. You can pause it before you should have a go. Divided by log 5. Divided by log 5. Then you can put that on the calculator. So log 9. That gives you 1.36. 1.36. That gives you 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 1.36. That gives So another part of logarithm is what? When you actually what change the base of it to. So when the base is actually what being changed. So for example, now if you have a log if you have log base equals to this, so that gives you 1.29. So if x equals to these two, you can, if x equals to log AB, so you can change the base to like a to the x equals to b. So taking log for base c, you take the log, make it as take the log for both sides. This one becomes this. Then it's not going to be what? So the same approach too. It's just for you to like add the base to than using ordinary logs. So let's now solve equations now. So if you have to solve this one, you want to find out what x will be. Solving equations to find out what x will actually what x will be. So so you have something like this. So the first thing is that you know that this is actually what this is equal, and you can remove the log. You can actually what remove the log straight away. So you know this is what this log 5. So by solving this thing, log 5 is going to be equal to 1. So you can change this one to log 5 times 2. You know that. So that gives you what's it called? That gives you log 5 is going to be 1. 1 times 2. This one is going to be 1. Then 1 times 2 is going to be 2. So you have 2 on this side. So you have what? You have 2 on that side. So, and so you have 2 on that side too. So when you look at this other part too, so that's why you see what 1 amounts to 2. So log 5x plus this plus log 25, this because 5 squared is 25. So it gives you this one. Then you know that log 25x equals to that 25x equals to 10, x equals to 0.4. Just pause that one and you actually would go over it. So this one too, is also the exponential. You take the log for both sides, log this and log 30. So this one is 2x log 5, and this log this. So 2x equals to log 30 divided by log 5. Then when you're done with the answer, divide it by 2 again, you get this. So it's just similar to the approach you actually used before. Don't forget that the 2x was brought forward because it's about powers. So this and this one. So plus this equals to, so when you brought this one backwards, you brought it here because it's power. You brought this one to there because it's power. So from there, you expand it. Then divide it, gives you this one. So the final one is this. The final one is when solving what? When solving this, in terms of B, you have like 2 unknown ones there. You solve this minus this plus 4 equals to this one. So since so because you can see 2 powers there, so when you say that let y equals to 3x, that means that 3x squared y equals to this. So it gives you what? Y squared minus 5y plus 4 equals to 0. So from there, you factorize it. Y minus 1, y minus 4 equals to 0. Then y is going to be equal to 1. Then y is going to be equal to 4 for both ones. So since you know initially that 3x equals to 1, that means that anything that relates to this thing, 3x equals to 1, that means that s is going to be equal to 0. Then for this one, so you see that 3x equals to 4. So you can now solve that one. If you say 3x equals to 4, you can take the logarithm of both sides, and you turn it around. This s equals to what? 1.25. So s is going to be 1.26 or 0. So that is that. So don't forget, there's going to be a full assignment for you to do at the end of the course, so that you can be able to have what's it called? Have a more comprehensive knowledge on it. So this question, you might try to pause it and have a go. So when you have a go, you'll be able to see, before you check your answer and see that you actually what it right. So I will see you again tomorrow. By tomorrow, we will finish off learning outcome 3. Then by next week, we should be done with learning outcome 4. So thank you.